All right, in this lesson, we're going to be looking at the greatest common factor. And I remember this goes back to, middle school, 5th grade, somewhere around there. So, objective simple, we're going to identify the greatest common factor. In other words, you got to think, what is the greatest number that they have in common? What's the greatest number that both these numbers have in common? Look at this example here, 6x to the 5th and 4x squared. What's the greatest that they have in common? What's the most you can take away from both of them? That's another way I like to think about it. What's the most you can take from both of them? Well, we can take a 3 from the 6, but we can't take a 3 from the 4. We can take a 2 from the 6 and a 2 from the 4, and you can't take any more than that. And then what about the x squared and the x to the 5th? Well, the greatest thing we can take from both of them would be x squared, because the x to the 5th contains 5 x's, the x squared has 2 of them, so the most we can take from both of them would be 2 x's. So we actually look at the lowest power when it comes to the variables. So let's just look at an example. So we have 3x to the 4th, 15x to the 3rd, and 21x squared. What's the greatest thing we could take from both of them? Well, or all three of these. So if we look at them all, the 3, this is a prime number, because really all you can make up at 3, if you look at a factor tree, would be 3 times 1. So we have to look at this 15. What makes that up? 3 times 5, and then 21 is 3 times 7. So what do they all have in common? Well, what do they all have in common would be the 3. What's the greatest thing we can take from all three of these things is at most we can take 1 3. We can't take a 5 from all three of them. We can't take a 7. The most we can take is a 3. So the greatest common factor is 3. And then what about the x's? What's the most x's we can take? Well, if you look at this, x to the 3rd, that's 3 x's. If you list it out, it's just x times x times x. At most we have is 3 x's there, while this at most we have x times x, and then this would have 4 of them. So what's the most we can take? Well, I could take 4 x's from this, but I can only take 2 from here. So the greatest I can take from all three of these is 2 x's. So the greatest common factor from these three things will be x squared. So there you go. 3x squared is going to be the greatest common factor of those three. Looking at something a little more complex, we have 54, 18, and 36. Well, if you look at the z, at most we can only take 1 z. You can see that there. This has 3 z's, that has 2, but at most we can only take 1. But what about our numbers? We have a 54, an 18, and a 36. Now, some of you might just look at this and be like, boom, 6 is the number. Others, it may take some time. So those that take a little bit more time, let's go ahead and take a look at a factor tree. So what's two numbers that multiply to 54? 6 times 9. And then to the 6 is 3 times 2, and 9 is 3 times 3. 18 would be 9 times 2, which the 9 can still break down to 3 times 3. 36 could be 12 times 3, and then this would be 4 times 3, which would be 2 times 2. So looking at this, and it's actually more than a 6 that we can take from all these. If you look at it, we have 3 3's here. But we only have 2 3's on the 18, and then we have 2 3's here. Now I'm going to just go ahead and rewrite all these just to make it a little bit easier to look at. So 54 is 2 times 3 times 3 times 3, or I could rewrite that as 3 to the 3rd power. And then 18 is 2 times 3 squared, because we have 2 3's there. And then here 36 is going to be 2 squared times 3 squared. Now we need to bring back in the z's, so let me just lasso this, bring it to the right a little bit, and then bring back in our z's. So 54 was z to the 3rd, and this is 18z, and we had 36z squared. So just like the variables, what's the most we can take from this? Well, this only has 1 2. All the others share 2 as well. Even though this has 2 squared, the most we can take from all three is just a 2. And then what about the 3's though? 3 squared seems to be our lowest power. So the most we could take from the 3's is 2 3's from each one. Each one of them contains at least 2 3's. We can't take 3 3's because we can't take 3 3's from this one. And you want the greatest common factor, so you want to take the most that you can of those 3. So we have a 2 times 3 squared. And then the highest, or the lowest power of the z is just 1, so we can take at most 1z from all of these. So this right here would be our greatest common factor. If we need it in number form, 2 times 9 is 18. So really the number we could take from all of those was an 18. At first sight, I was thinking a 6, and that just shows why sometimes that factor tree, when the numbers get a little bit bigger, is going to help you.